right, hey y'all, it's Mr. Kyle, Myers Mathematics, and let's just jump into it. So I worked out this entire thing, and I thought I hit record, and I did not. So I'm a big dummy. But this is what I did, and I'm gonna just kind of walk you through what I did because it was actually kind of a long video. So I'll probably make it shorter anyways by doing this. So if you want to see me work it out in real time, let me know in the comments below. I'll rework the video for you. But this was a little crazy, and this method is a method that I'm not like super familiar with. So I was kind of like working it out while I was reading it and everything, and just kind of like figuring some stuff out for myself for the first time and how this method works. It's actually really cool. But let's read through it and look at where we're getting the answers for the different things here. So Newton's method seeks to approximate a solution f of x equals 0. Which, by the way, we can plug that in. So we can find out what the actual answer is in a lot of cases. But it's approximating it. So this would be a way that you could approximate certain numbers without a calculator. Like, for instance, here, if you plug in 0 for f of x is equal to x squared minus 2. So that's right here. Right here. So all of this is me just plugging in 0 for f of x and then solving. So x is equal to plus or minus the square root of 2. This method looks like it ends up only approximating the positive solution, but I think that if you started off with an approximation of -1 instead of +1, then maybe it would also give you the negative square root of 2 if you were to keep going with it. I don't know for sure. I haven't tried it. If you want to try it, let me know. But let's go ahead and keep reading. So Newton's method seeks to approximate a solution f of x equals 0 that starts with an initial approximation x sub 0 and successfully defines a sequence x sub n plus 1 equals x sub n minus f of x sub n over f prime of x sub n. Ooh, that's a mouthful. For the given choice of f and x sub 0, so they give us a function, they give us an x naught or an x sub 0. Write out the formula for x sub n plus 1. If the sequence appears to converge, give an exact formula for the solution x, then identify the limit x accurate to 4 decimal places and the smallest n such that x sub n agrees with x up to 4 decimal places. Again, quite a mouthful. The formula is a mouthful. All of the text is a mouthful. I don't think I'll get too much into it in the next couple videos that are all on this same topic as far as like understanding what all that means, but we'll get into what it means a little bit here so that we have that understanding moving forward. So like I said earlier, I plugged in 0, so I know what I'm shooting for. I would recommend doing that. That way you know what you're trying to get to. We're trying to get to the square root of 2. So then I wrote it out. Say, okay, so n plus 1, x sub n minus, and then what if I plugged in x sub n into f of x? It wouldn't look that different. I would just call this x sub n squared minus 2, and that's what I did. And I also took the derivative. I took the derivative kind of the long way to show that when you take a constant's derivative, the reason why it's 0 is actually also because of the power rule. Because if you have a constant, you have 0 powers of x, so you're timesing by that power 0, and then 0 times anything is 0. So I was kind of getting into that a little bit. That's kind of a side topic, not super important. The derivative of f is 2x. So if we're plugging in x sub n, then it would just be 2xn. So 2xn. And then I cleaned it up a little bit. So I split up this fraction. I can split it up here and here. So I split that up, and then I can simplify it down a little bit, and I get this, which is still kind of a recursive formula. They said give an exact formula, which I'm thinking it could mean an explicit formula. But I hope it doesn't mean that, because the explicit formula would be really hard to get from the recursive formula. I mean, maybe you got it and you're a genius, or maybe I'm just like not seeing like an easy way to turn this recursive formula into an explicit formula, but it looks hard to me. It looks like it would be really difficult. I don't see any really obvious patterns. If you look at your t-chart here, it goes from 1 to 3/2 to 17/12 to 577 over 408, which, by the way, 577 is a huge prime number. I checked, it's prime. So it seems like the numerator is always a prime number, and how do you even make a pattern out of that? There's not really a pattern of prime numbers. Like, people have tried to crack the code, and people have gotten pretty close. I mean, you can get really large primes by taking 2 to the power of n and then minusing 1, but it doesn't always work. It just mostly works. So there's not a formula to give you a prime number. And that's what it looks like the numerator is doing. It looks like it's going to be a bigger and bigger prime number every time. And then the denominator is a composite number, but it's a composite number of successively larger prime numbers. So the pattern, whatever it might be, is crazy. So when I thought I was recording in the last video, I was like, hey, if your professor wants you to write out the explicit formula, one, I'll pray for you, and two, let me know in the comments, because I could be up for the challenge, but I would need to like know that it would benefit somebody. Because like my time is valuable too, right? So it's like I would want to do it if it would benefit somebody, but if it's only gonna benefit me just to get the answer and be like, oh, I did it, like it's like it's not that big of a deal. So yeah, as far as the explicit formula, I don't know, but we did simplify the recursive-ish formula that they gave us. So that's kind of the answer to that. Our choice of f just means that we plugged it in. X sub 0, writing out the formula. We also did several t-chart values, which I feel like is going to be part of what will make the professor happy, so they can see that you're thinking through the problem. So I'd probably recommend having that t-chart in there as well. Identifying the limit. Well, the limit, theoretically, if Newton's method of approximation works, then theoretically the limit should just equal whatever x equals when f of x equals 0. And I think it does. Now, I don't know for sure, but I trust that Newton's a pretty smart guy. So I think his method works. And down here, I wrote that the limit as n goes to infinity of x sub n is the square root of 2. And again, I don't know that for sure, but if you look at the decimal approximation, I have it pulled up over here. The decimal approximation of 577 over 408. Oh, wait, here it is. Yeah, so the decimal approximation of 577 over 408 is actually 1.414215 blah, 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 blah. The square root of 2 is 1.414213 instead of 5. Blah, 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 blah. It's really close. So I want to just go out on a limb and go ahead and say that it is actually approaching the square root of 2. So if we went to infinity, theoretically, that number should be equal to the square root of 2 exactly, which is, if you wanted to write, so identify the limit x accurate to 4 decimal places. So the limit accurate to 4 decimal places would be 1.4142. That is 4 decimal places. It rounds down to 2. And the smallest n, such that x sub n agrees with x up to 4 decimal places, it's only 2 decimal places for 17/12 when n is 2. But when you take n to 3, all of a sudden it's accurate to 5 decimal places. It has a huge jump in accuracy. So by the time we get to n equals 3, we are accurate up to 5. So also it would be accurate to 4. And so that would be the n value. N would equal 3 would be the accuracy there. So hopefully that's been helpful. And yeah, so this time I did double check that we're recording. So thanks for sticking to the end. Go check out the 5 math mistakes everyone makes and how to avoid them. That is on my website, myirishmathematics.com, where you can also check out other things like what I do as a math teacher, a math tutor, content creator, etc., and how I can help you. So you can go check that out, and I'll catch you in the next video. Blessings, y'all.